Scientific notation is a way that scientists easily handle every large number or very small number to be able to work with them. So right here I have a very large number and a very small number. And when we do scientific notation, we have one number, we want one number to the left. So the decimal point of a large number is right here, and I need it to be so that there's one number to the left. So I'm going to count 1, 2, 3, 4, 5, 6, 7 spots to get to where I need my decimal to be. So my final answer in scientific notation is 2.7 times 10 to the 7th. So if I move my decimal to the left, I have a large number, and if I move it to the right, I have a small number. Large numbers will have positive exponents, and small numbers will have negative exponents. So in this case, I need one whole number to the left, so I need my decimal to be there. So I'm taking this small number and I'm moving it 1, 2, 3, 4, 5 spaces, and when I move to the right and have a small number, I'm negative. Some scientific notation, 5.6 times 10 to the negative 5. Let's put it into use. I'm going to multiply two numbers, and they're both scientific notation, so I can break them apart. I can take 7.14 times 4.2 and then 10 to the negative 7 times 10 to the 12th. When I multiply this piece right here, I get 29.988. Like bases, I add my exponents. So hopefully you can tell right here I'm not in scientific notation. I have to move it one to the left. When I move it one to the left, when I go to the left, I'm getting larger, so I add. So my final answer in scientific notation is 2.9988 times 10 to the 6th power. If I had to write that in standard form, it would be 2, 1, 2, 3, 4, 5, 6. So this would be standard form. One more example. This time I'm going to divide. What I'm really doing is taking 1.2 times 10 to the 8th, and I'm dividing it by 9.6 times 10 to the 5th. So what that looks like is 1.2 divided by 9.6 and 10 to the 8th over 10 to the 5th. When I simplify this right here, I get 0.125 times 10. The base. I move this up by subtracting 5, so I'm going to move it up, or another way, if you cross the line, you change the sign. So either way, you're going to get a 10 to the negative 5th. So I have 10 to the 3rd right there. So far that's a good answer, but I'm not in scientific notation. If I have to move this to the right one spot, I'm making it smaller. So my final answer is 1.25 times 10 to the 2nd power.